Welcome back to PRATIK Academy. In our earlier video, we have started our new chapter, that is towards green energy. Okay, so we have discussed about energy, type of energy, then forms of energy. Then we have also discussed about importance of electrical energy, and at the end, we are at the question of how to create or generate electrical energy. So law of, for that purpose we are using law of conservation of energy. So what is the statement? It states that energy neither be created nor destroyed, but it can convert it from one form to another form, but total amount of energy remains constant. Okay, so this law gives us idea. Which idea? That energy can be converted from one form to another form. Energy can be converted from one form to another form. So by taking this idea, we are generating here electrical energy. Okay, so in this diagram, if we see, we are getting here output as a electrical energy from this powerhouse by taking some input energy. Okay, so we are taking any form of energy as the input energy supplied to powerhouse, and from this powerhouse we will get output as the electrical energy. So it is this simple, based upon law of conservation of energy. So next is, we discussed here, we get electricity for from powerhouse, but what is the next question? How electrical energy is generated? What is the mechanism behind that? So there should be any mechanism, or there must be any mechanism to generate electricity or electrical energy. So this mechanism or principle is electromagnetic induction principle, which is invented by great scientist Michael Faraday. Okay, so what is that principle? Let's study. So this is the simple diagram explaining or giving some basic idea about electromagnetic induction. This diagram, if you recall, this diagram you have already seen in your 8th or 9th standard book. So in that year you have studied that, or we know that when electric current pass through circuit, it will generate magnetic effect. Okay, we know that when we pass electric current through wire, it will generate some magnetic effect. So in this experiment, if we wound our wire over a iron rod and passed electricity through this wire, then this iron rod is becoming magnet or showing properties of magnet. And if we take any iron particles near to this, it will attract towards it. So here, by using electric energy or electric current, we are generating magnetic effect. So this is our earlier earlier study part. So if you reverse this, that means if you use magnetic field, then also we can generate electrical effect in reverse way. Here, using electrical current, we are generating magnetic effect. In reverse way, if you use magnetic field, we can generate electrical effect or electric current. This is the basic idea behind electromagnetic induction. So this is the in detail. So what is the principle of electromagnetic induction? It simply states that whenever magnetic field around a conductor changes, potential difference is generated across the conductor. And we know that when potential difference is generated, there is flow of electrons. Okay, and this is the principle. And what is the law of Faraday's law of induction? So it law states that whenever the number of magnetic lines of force passing through coil changes, current is induced in the coil. So which word is very important here? Change. Change. Which is changing? Magnetic field. Here magnetic field. So if there is a change in magnetic field, then and then only there will be generation of electrical current. Okay, so we have a separate chapter for this point in our science 1 part. In that we will discuss in detail this part. So here just remember these two principle or these two statements: principle of electromagnetic induction and Faraday's law of induction. What is important here? So there should be change in magnetic field. Okay, so if there is no any change, there will be no any potential difference or electric current generated. Okay, now so consider this diagram. So in this diagram, so this is the magnetic field. There's the N pole and S pole of magnetic field. We have placed here coil A, B, C, D, and one shaft is there. Okay, or axle is there, you can say. And as we know that we have to change the magnetic field associated with this coil. We know that magnetic field is represented by magnetic lines, and these lines are starting from N and goes to S pole. So lines of magnetic lines are from N to S. Okay, now here when we rotate this coil by some mechanism, when we rotate this axle initially, then as this coil is over this axle, so when we rotate this axle, coil also get rotated, and when coil rotates, then magnetic field associated with coil is changing continuously, and there will be generation of electromagnetic there will be generation of electric current. So here we have keeping magnet stationary and coil is rotating. So due to change in magnetic field associated with coil, there is a production of electric energy. So this is the one way. In another way, here we are rotating magnetic field by some mechanism. Okay, and our coil is stationary. And same principle, when we rotate magnetic field, then lines of magnetic flux associated with this coil is also changes, and when there is a change in magnetic field associated with coil, there is generation of electrical energy. Okay, here, so here magnet is rotating and coil is stationary. By these two way we can generate electricity. Okay, either we have to rotate magnet or rotate coil. So this is the principle. Then there is a device which is called as electrical generator. So what is electrical generator? Electric power generating machine based on principle of electromagnetic induction is called electric generator. So this is the definition. I will repeat once again. Electrical power generating machine based on principle of electromagnetic induction is called as electric generator. So when we recall this principle, we know that one field or either magnet or coil should be rotating here. So if we look at this diagram, then at the center part NNAS, so central part we are having magnet, and surrounding to this we are having coil. Okay, so we are here having rotating electric magnet. That means when we rotate inside magnet, then magnetic field associated with this coil, it changes and generation of electricity is there. Okay, so what is the important here? Rotation of magnet or rotation of coil is very important. So for that rotation purpose we require one device. This device is called as a turbine. Okay, so turbine is a device which is used to rotate the magnet in the generator. So in this generator there is a electrical magnet. If this magnet is stationary, there is no any generation of electricity, and it should be or it must be rotating for generation of electricity, and for rotation of that we are using turbine. So when turbine rotates, then this shaft or axle is rotating, and the magnet or electromagnet based on that shaft is also start rotating. Then based upon type of energy at the inlet, because initially turbine is also stationary, we have to give some energy initially so that turbine start rotating, and depending upon that energy turbines are classified into different ways. We can call, we can have water turbines, we can have steam turbines, we can have also gas turbines are there. Okay, depending upon type of energy. So that part we'll discuss, or what are the different energies used to generation of electricity. That part we'll discuss in our next video. Okay, so here again there are some list of different video series we have already published in our YouTube channel. Take use of this, and if you like this video, please share this video with your friends and subscribe our channel. Thank you for watching our video.